Okay, well, awesome. Welcome everyone to the latest episode of the View Dependent podcast, where we speak to leaders in the world of radiance fields and hyperreal 3D reconstruction. So today we have our guest is Will Eastcott, who is the CEO of SuperSplat, which is what I would say the leading platform for editing your captures. And we're very excited to have you on this show today.
Thank you very much, Michael. Looking forward to chatting.
Happy to have you here. Yeah, it's very exciting to have you here because I know you from Twitter mostly, where you post all these amazing updates of SuperSplat, and now we have you here to talk about the latest features. So,
yeah, I'm glad to be torn away from Twitter. I spend far too much time on it as it is.
Yeah. So thanks again for joining us today, and kind of want to get started with what initially drew you to the world of 3D, and like how did this like evolve into your current focus on to like real-time rendering with tools like SuperSplat?
Oh, well, in a single word, it's games. I mean, I don't know when you guys started playing games, but I think I was about 6 years old when I got a Pong system that I could like plug into my black and white television. And then I got my first 8-bit computer when I was about 8 years old, and I started programming BASIC at that point. And pretty soon after that, you started to see 3D games being released. I mean, they were super basic at the time, but some of them were like super fun. And ever since that point, I've been absolutely fascinated and obsessed with games hardware. And yeah, I mean, it took me all the way through to studying computing at Imperial College in London. And then shortly after that, I joined a company called Criterion Software, which makes game technology. So I've spent almost my entire career working on it.
Nice, that's incredible. And so how did that kind of translate into your time at like PlayCanvas as well too? Because so for people who don't know, Will also runs the company PlayCanvas, which ended up actually being acquired by Snap, which is pretty incredible. But yeah, I'd love to hear more about it.
Yeah. Well, I mean, I spent many years working at big names in the games industry like Electronic Arts, Sony, Activision. And that was super fun because I got to work on some pretty big named games IP. And I got to work alongside some really smart people. But when 2010 rolled around, the spec for WebGL was announced. And somebody with my background of C++ and closed source development, it was all very new to me. I didn't know anything about JavaScript, but it struck me that the web was an incredible distribution channel for content where you could publish and get that into the device of your end user without having to download and install anything. I mean, okay, you're streaming content, but you just point your browser at a URL and you can access this content. And I thought, this is one of those very few moments in my life where I have an opportunity to take advantage of a complete sea change in how the web works. So like, it's not every day that 3D graphics gets introduced into a whole new, massively utilized platform. So yeah, that just blew my mind. And almost, I mean, I'm not saying overnight, but like within, maybe just a few weeks, I'd handed in my notice to Activision and I set about building PlayCanvas.
Interesting, yeah. So you are like the first adopter in WebGL and now basically in Gaussian Splatting or in radiance fields in general. So how did you get started with radiance field? Was it photogrammetry already, or did you start with NeRF, or was your first touch with Gaussian Splatting in 3D reconstruction? So how did you get interested in it?
Yeah, good question, Janusz. So NeRF kind of passed me by. I was seeing some stuff on Twitter and it looked interesting, but it didn't really look like a good fit for my team, and I couldn't quite. it wasn't just obvious to me how I could take advantage of that. So but then when the INRIA paper got published in the summer of 2023, there was a lot of activity straight afterwards where people were taking the point clouds from the kind of zip file that was delivered along with the INRIA paper, and they were building little kind of like pet renderers for these that implemented Gaussian splatting, and then sharing online little demos that you could inspect. And I thought that was really inspirational. And I thought, wait a second here, we've got this incredibly powerful JavaScript runtime in the PlayCanvas engine. We've got some really great libraries for building tools. We already have the PlayCanvas editor and a bunch of other tools too. And it's just, we're very good at building sort of high quality web-based tooling. So I thought there's a real opportunity for us here to build something that allows people to be able to kind of work with Gaussian splats a lot more easily, because I think in the early days, there were all these kind of obstacles and roadblocks that stop people from getting involved. Like it was really hard to see how you could get started. But if you fast forward a year to today, I mean, we've got like really good tools now. We've got highly optimized runtimes. And it's very easy for people to just quickly generate a splat, clean it up, throw it into your engine of choice, and publish an application. So we're just kind of trying to help that along.
So you're basically focusing mostly on editing. So this is your use case, right? So you are not offering any training currently?
So we don't. Yeah, that's correct. So we don't have any kind of like training service as part of the SuperSplat platform today. We are definitely focusing more on building like a Swiss Army knife for working with splats. And, the reaction to that's been really positive. I mean, I think we've made some really good calls there. And, but alongside the editing side, it's important to also consider the kind of runtime that we have, and also the main kind of scene editor tool that we have. Because, you can take your PLY file from whatever like splat generation software that you happen to be using, whether that's like Luma or Postshot or Polycam or whatever, put that into SuperSplat, edit it, clean it up, compress it, take the output and put that into the PlayCanvas editor, and then you can apply all of your host effects. You can maybe mix and match splats with traditional mesh-based 3D graphics, and add all of your behavior and user interaction and whatever else you might need in your application, and then publish it. So I guess, yeah, we're more focused on the kind of like the editing and scene building and publishing end of the pipeline.
Right. I think one of my favorite parts of SuperSplat is when Gaussian splatting first came out and was starting to be able to be trained by consumers, the potential file size would be massive, and it was very easy just to go to SuperSplat and kind of like drop it in and compress it, and instantly it would drop from like a gigabyte and a half to a much more manageable size too. But it was also very handy just to, as we were taking a look here, take a look at some of the cropping tools and functionalities, and really be able to get a bit more precise with what your scene was. What are some of these other, like, I guess actually this is a good example here, is just like with the ring selector. I'm curious if you could talk a little bit about some of these additional functionalities that have come to SuperSplat.
Yeah, I mean, it's funny. I guess when we started, the first thing you do when you manage a software project is you build your roadmap, right? But I think as time's gone on, we've ended up building this community, and I think it works a lot better for us to just like listen very closely to the community, find out what it is they're trying to build, find out what are the obstacles preventing them from, creating what they want to build, and then kind of responding to that quickly. So our roadmap now is like super short. Like we have a ton of feature requests and stuff on the GitHub repo, but we're just like week to week, we're just kind of like picking something that we consider to be the hot feature that developers need today, right? So it is quite a reactive process, but a lot of the features that we're working on right now are related to sort of things like being able to copy and paste splats. So today we did the release of 1.6, where you can make a selection, like a sub-selection in your scene, and then just move it, which is cool. Don't get me wrong, that's fine. But it's really step one in a two-step process, right? Because now that we've done this, we can now build copy and paste, which means that, you could say, duplicate the bowl of fruit on the work surface there. Or let's say, for example, you had a room with a chair and you wanted to kind of move the chair. Well, if you move the chair, you're going to like cut a big hole in the floor as well. So you need to be able to like copy and paste another bit of the floor to kind of fill the gap that you've left. And so copy and pasting, I think, is going to be a major feature. But also the kind of, as part of that work, we had to re-architect how we kind of internally store all of the splats in memory. And this is enabling to do lots of other cool things. So also next on the list is recoloring. So we'll be able to allow people to modify hue, brightness, contrast, and so on, and just recolor splats. And maybe one day even do things like relighting. But yeah, I mean, we're kind of focused on a lot of those areas. I tell you what, though, Michael, I do want to just go back to something that you mentioned just before, which was the size of splats. So yeah, I mean, like a lot of those initial point clouds from INRIA, they were about 1.5 gigabytes or something, which is crazy. It's not just like a significant amount of data to work with just on a machine, because you can run out of memory and stuff. But for end users who want to download content and view it, say in their browser, that's a deal breaker. No one's going to wait around for that long. So compression is incredibly important, and we've spent a lot of time thinking about the best way to deal with compression. So we today have our own format, which is like a quantized PLY format, which is great, and it reduces the file size by, I think it's like 5x or something like that. But at the moment, that format loses spherical harmonics. It doesn't serialize those, so that's the next step, is to allow you also to store the spherical harmonics. But it's a really cool format, and one of the reasons why it's awesome is that the data in the file, you just shunt it into memory, and then you pass it straight to the GPU. It doesn't have to be decompressed. So the GPU consumes it in the format that it's serialized. So it's incredibly optimal for size-wise, but it's also very quick to load and very quick to upload to the GPU memory. So we've spent a huge amount of time like researching that and coming up with a good solution, not just for the actual file format, but working on a runtime so that the shaders actually operate on that compressed format.
Oh, that's incredible. By the way, what is the maximum file size I can upload to SuperSplat? So is there a limit?
I think somebody suggested the other day they tried to upload something that was about 4 gigabytes. I'm not like, there will be a limit based on the amount of memory that a browser tab can allocate. I should point out, actually, that SuperSplat is available as a PWA, or progressive web app, which means that you can install it to your desktop. Now, I don't know for sure, but often PWAs can have certain restrictions lifted or relaxed. So maybe PWAs are granted more memory. But I would say that, like, number one, we haven't come across anybody yet who has hit that limit. And also, number two, we are constantly trying to think of smart ways to make better use of system memory. So, for example, I was chatting with Donovan Hutchins, who leads the SuperSplat project today, and he was talking about the fact that he wants to change the way we load PLY data so that we're going to like stream it instead of load it all, sort of, which means that we can potentially avoid having to allocate a very large buffer in advance based on the size of the file and then like copy the memory. And instead we can just like stream it and process it on load, and the same for saving. So yeah, I mean, these are things that, our customers hit and we lose sleep at night thinking about. So yeah.
Right. One of the really nice things about the PWA is like as a pro tip too, is you can actually delegate whenever you open a PLY to just default to the SuperSplat app. So as soon as you double click on it, it just opens right into SuperSplat too. So for anyone's listening at home, it's a great way to kind of just like, continue to speed things up a little bit and just makes it really smooth. So definitely, guys, I would suggest checking that out.
Yeah, exactly, Mike. That's absolutely true. And I think most people don't realize, but when you load a PWA like SuperSplat into, say, Chrome, there's a little icon in the address bar that it's kind of like a little download button. And if you hit that, it says, do you want to install this to your desktop? And then it installs it. I think most people don't do this, but actually it's cool because then you can have it on your start menu, on your like icons bar or whatever. You can even install it to your home screen on say like an iPad. Like SuperSplat works everywhere, not just desktop operating systems. Like if you want to run it on iPad, it actually works really well, and it's got touch input and everything.
Okay, but how is the usability then on my iPad? I didn't try it yet on iPad, so because I mean it's very different if you use your fingers and mouse.
Yeah, it's actually surprisingly good because as you know, like it's got like a brush tool. So to actually kind of paint with your finger is like even more natural than using a mouse. So I'm kind of a big fan of it. I think the only problem for most people is it's kind of like exchanging files between applications because you've got to get the PLY from somewhere into SuperSplat, and then once you've edited it, you've got to save it out and get it into some other application where you're going to build an app. But yeah, I mean, besides file management, I mean, it's actually a really fun app to use on iPad. So yeah, try it out.
I will do, yes. Actually, when it comes to new features and feature requests, what is your main source of getting the feature requests? Is this mostly GitHub, or is it Twitter or any other social media channel? What do you use for people who want really badly a specific feature and to make it happen?
Yeah, it's mainly GitHub. So I think there's probably 30 open feature requests on GitHub right now. And yeah, I mean, it's a really useful tool for us to be able to collate and look for trends in terms of what developers are asking for. I mean, for example, a really common thing that's been requested many times is a measurement tool. So you can click two points on a splat and it'll tell you the physical distance between those points. And without GitHub, I never would have considered that feature, but actually it's considered to be quite important for developers. So yeah, it's really fun to use GitHub as a mechanism just to kind of like get that information. But as you mentioned, like X, LinkedIn, Reddit, there's a really vibrant Gaussian splatting community on Reddit actually that I joined a few months ago. And yeah, so I mean, I think you have to kind of, it's a combination, right? Like it's reactive. You have to let people log their feature requests, but at the same time, like me and my team need to go out and just talk to people, understand their pain points, try to find out why they want to be using 3D Gaussian splatting, what applications they want to be building.
Have you been surprised at all in terms of like the way that radiance fields like Gaussian splatting has kind of like taken over in terms of adoption rate?
Well, so my feeling is right now, in terms of Gaussian splatting, we're still really in an experimental phase. I think the research is still going ahead at a breakneck pace. We're seeing new research papers being published every few days still. There's some super exciting research covering areas like relighting, animation, optimization, improving photorealism, lots of different areas that are really exciting. But at the end of the day, I think it's going to take longer for your typical, say, digital agency to embrace the technology, because we have to make the workflows easier. We have to educate people better, and we have to also educate and communicate, how people should be using this technology, where it's relevant, what its strengths are, what its weaknesses are. And I think there's so we might understand these points very well, but I think your average 3D content creator probably doesn't understand the details yet.
Yeah, and basically nobody, because here my city, I would consider myself one of the few people at all interested in this tech, and also one of the few people who really know that it exists at all. So I think there's a big gap between your bubble on X or so, where people are posting all the time about it, and between real life, where people really are not aware of it.
Yeah, there's just going to be a lag, right? Like, I think for the knowledge to percolate through the content creation community, there's just going to be a delay. But like, I personally have very high confidence that 3D Gaussian splatting is going to be transformational for like certain industries. But there's going to be other industries that maybe it won't be such a good fit. But we will see that develop over time. We can make predictions, but I'm sure things are going to change rapidly, and we just have to be able to respond to that.
Yeah, and so I kind of want to highlight one of these industries that I think is a really natural fit. And it's actually an example that I think gets demonstrated really well by SuperSplat, and that's the world of education and being able to show things in really high fidelity, but also embed additional information. So I wanted to kind of chat about, how or any of these examples that you've seen or created in this realm.
Yeah, so the statue visualizer here is it's essentially a technical demo that we built on the PlayCanvas team to promote Gaussian splatting support in the PlayCanvas editor. So once you had your cleaned up splats, you could import those splats, those PLY files, into the editor, and you could add a user interface. You could add like post effects and really cool like particle effects that you can see going on there. Yeah, I mean, I guess really the purpose of what you're seeing here was really to educate and inspire developers as to the kind of thing that they could be building. And one of the reasons why I'm so excited about this is that like the level of expertise required to build this application is so low compared to like a traditional mesh-based approach, where you're going to need really to find a 3D artist, somebody with an understanding of how to like construct these meshes. Maybe if you did it with photogrammetry and you just you had like you still had a mesh-based solution, but even then, like the graphical fidelity would not come close to what you're seeing here. This is essentially photorealistic and achievable by somebody who doesn't really have much knowledge of 3D. So that's really, really, really cool. But it does really give you a taste, doesn't it, of where, say, education might go. So whether this is teaching, anatomy or history or science, this is a good way for you to be able to digitize reality and communicate something to someone. It was funny, I was on LinkedIn and somebody was actually making a comment on this application and saying that they thought it was a shame, right? Like, because they thought people should be going to museums and this would stop people from going to museums. And I think not realizing that like 98% of people living around the world probably can't access these kind of artifacts. And wouldn't it be great if they could just go online, and not just go online, but imagine in VR or AR, they can get like a convincing feeling of what it's like to kind of actually experience something like this.
Yeah, it's actually very funny timing because right before you joined like the green room, Janusz and I were actually talking about this exact topic about scanning museums, and so one of the things we're saying is that a lot of museums only showcase only like 4% of their collection at a given time on the floor, and the rest of it just is never seen by the public. And I feel like this is such a compelling way that you can allow people to, or you can allow museums to actually showcase the entire breadth of their collection and allow them to also see what are the pieces that people are most interested in actually looking at? And you could rotate based upon some of that metrics as well. But one of the other points that Janusz and I were talking about is that, that the Met is here in Manhattan, just a couple blocks away from me. And so one of my plans is to kind of run in there, maybe on like a Tuesday morning or something, and start just taking, hundreds of images to create our larger reconstruction of some of these places for people.
You should do it. It's funny though, because museums are actually, they do have terms and conditions, which some of them are happy with you to do that, and some of them, I think they're just trying to update their kind of terms and conditions to kind of allow this kind of thing, but you have to kind of check before.
Yeah, no, I was asked to leave MoMA twice, creating nerfs inside of it, but that was also a couple of years ago too. So I think at this point, there's a larger openness to hyperreal 3D reconstruction.
Yeah.
Also, what I found when I started with this tech, that a lot of paleontology people started following me on X, and I was really surprised because there's also like a huge community. You are scanning skeletons of dinosaurs to visualize them, and this is something, I mean, it's like a perfect use case just to preserve what you found, right?
So yeah, actually, that was what that application was supposed to be. It was supposed to be for dinosaur skeletons. But I went to the Natural History Museum first, and if you've ever been there in London, it's so dark, and also dinosaurs are pretty big, right? So whereas like those statues were a lot smaller, so it worked out that the statues were beautifully lit, and they were easy to get like a good set of photogrammetry around them. So I ended up like in real time making a decision. No, we're not going to do dinosaurs. We're going to do statues.
And so one of the things you highlighted too in that example is that, with the radiance of representation, in this case is Gaussian splatting, you can build upon just the visualization of it. And you're actually able to pull in different aspects, whether it's like text-based or, place it in larger scenes. And so I wanted to ask you, like, how does the larger PlayCanvas engine kind of like supercharge the ability to pair it with a radiance field?
Yeah, it just makes that super easy, actually. So if you pair the PlayCanvas editor with SuperSplat, so SuperSplat allows you to very rapidly, just in a few minutes, isolate the target object that you've scanned and remove all of the background, clean up any floaters, any kind of like stray Gaussians that might be hanging around in the scene, to make it look really nice and crisp. And then you take that, add it to your PlayCanvas scene, and because you've removed the background, you probably still want a background in your application, right? So in the statues demo, you saw that there was like this really beautiful photographic rotunda in the background. And that's actually just essentially a cube map. It's just a texture. It's loaded from 6 images, like 6 WebP images. And instead of being like a gigabyte, it's like 6 100 kilobyte images, but it looks photorealistic. And for the perspective, like, it looks fine. If you pulled out like about 6 meters, you'd start to realize it's not like actual geometry, but it works really well. It's really effective. And then to build the interface, that's just HTML. So yeah, in the PlayCanvas editor, you can just crack open an HTML file, just add the text that you want, yeah, like it's very easy. It's very kind of a visual way of building a 3D scene. But yeah, so it's I'd say the only thing that was a little bit complicated that might be beyond your average developer's skills is the transitions between statues, where we run this kind of like shader effect on the individual Gaussians, and it looks amazing though. Like, the code is all there. It's open source, so if anybody wants to take it, but to develop that's not straightforward. You need some understanding of how vertex and fragment shaders are written.
And so I kind of also wanted to chat a little bit about some of the integrations. And so recently Snap held their Connect, and they announced the version 5 of their spectacles. And as part of that launch, they spoke a little bit about how radiance fields like Gaussian splatting were getting support within Snapchat's Lens Studio. And so I wanted to since PlayCanvas and SuperSplat are the parent company is Snap, I kind of wanted to talk about like that pipeline and how the two kind of play into one another.
Yeah. So one of the key features of SuperSplat that I think is really important is that it's engine agnostic. I was very keen not to build it as something that was like tightly integrated into the PlayCanvas toolchain. So, you can use it quite happily with, Unity, Unreal, whatever, and of course Lens Studio. So, yeah, if you've conditioned your splat in SuperSplat and you save it out, you can drop that PLY file into Lens Studio and use it in exactly the same way as you would in the PlayCanvas editor. The Lens Studio runtime that actually renders the splats, funnily enough, it shares a lot of code with the PlayCanvas runtime because we work at Snap. We can actually, every learning that we make, every optimization that we make, we can share that as like an overall team. And it means that any discoveries or advances that are made on that side as well, we can factor those into the PlayCanvas runtime. So it's a really great partnership that we have working together at Snap. But it's maybe not obvious, but there are already lenses that are published to Snapchat and Spectacles that use Gaussian splatting. So there is one. If you were to Google like Snapchat flower crown, that's a Gaussian splat. So you can have like a beautiful sort of crown of flowers on your head. And that's just simply captured from photogrammetry into a splat, cleaned up in SuperSplat, published to a lens in Lens Studio, and then published out to Snapchat. So yeah, I mean, it's a just very quick and easy way to get really awesome looking lens AR experiences published.
So it's not a shader, it's a splat running in an app, or is it in a shader? I mean, if you have the flowers, right? Is it really a splat running on?
Yeah.
Yeah. Okay.
Yeah. So yeah, it's I think over time you'll see more and more lenses come out with that somehow leveraging 3D Gaussian splatting, and that's really my job, is to make it easy for people to build these kind of experiences. So yeah, if that doesn't happen, then I failed.
So I'm curious as well, kind of along those lines for creating those environments. Have there been any like really interesting or like niche use cases where someone has been just creating something or cleaning up or preparing within SuperSplat / PlayCanvas you've come across?
Good question. I mean, like, it's very fun to have conversations with developers where they're kind of showing their results as they work. We see a lot of developers doing stuff around heritage, like going out and capturing like historical sites, and we've seen people trying to experiment in how to get the highest possible quality for capturing humans. We've had a developer a few weeks ago who worked with us to really boost the quality of our splat rendering. And he did this because he sent us a capture of, I don't know whether his head or like his friend or something, but he sent us a head and a hand. And he said like the quality should be better. And we realized that we weren't getting quite that last few percent of photorealism because we weren't rendering with the spherical harmonics. And that prompted us to go back and add that both to the runtime and then load spherical harmonics into SuperSplat and have you be able to like mask those off or render them. And so like just through kind of speaking to developers and understanding their use cases, and like often we don't spot that there's a problem until our developers tell us. So it's just like a really important part of that iterative loop that we've got into with the community. But yeah, in terms of like really strange, to answer your original question, like niche use cases, Yeah, I mean, I've not seen anything like, out of the complete ordinary. I mean, yeah, it's people scanning vehicles, rooms, furniture, clothing, humans, and their pets sometimes, stuff like that. I mean,
Yeah, and I've been actually curious, whose hand that was for the spherical harmonics release, because I felt like that was
you
a
saw
huge
that,
update. Yes, yeah, and so I was actually thinking during that release, like, wow, that's a lot of detail on this person's hand. So
Right.
it's kind of funny that was the initial intention. And one of the questions too. So something that's happening actually right this second is there have been a lot of like legacy platforms, or you could call them legacy platforms, but they're platforms like Luma AI, for instance, which got very early into the world of radiance field capture and reconstruction. And obviously they've now since pivoted towards Dream Machine. And with that too, a lot of the GPU allotment has really gone into the world of Dream Machine. And so some feedback that I've gotten is that people are looking for places to distribute their or share links of their captures. And so I was curious to talk about like the ability to do that within like SuperSplat, or like how people can like give an interactive scene or to someone else.
Yeah, you might have seen me do this online already. Actually, normally when I share a link to SuperSplat, I use a query parameter in the URL which points to a file on GitHub. So SuperSplat can already do this. But it does require that your PLY is kind of like sitting on some public server somewhere, which is obviously a little bit inconvenient. But I totally agree with you. I think being able to share content is highly desirable. I personally, I've thought about this a bunch. Like, I think it'd be kind of cool if there was some kind of maybe temporary storage that we could set up for SuperSplat. And it's just like, hey, your Splat will be live for 7 days and then it'll disappear. And that's just the way it is. And yeah, I mean, we could do something like that. Maybe that will be something we address in the next 6 months or so. But yeah, like I think that would definitely help people. And I think it would, because at the end of the day, people love to interact with live content. They don't really want to look at images or videos or whatever. They want to like click a link and experience the content. So yeah, I mean, that would be a cool feature.
And because your background is in computer graphics and games, especially, so what do you think about applications and games? Is there something which is already going on? Is there something happening, or is it still not yet there because it's not like a mesh? You cannot really apply the same features or effects to Gaussian Splat. It's really much harder to manipulate it because you don't have the connectivity right between the points. It's just a point cloud in the end. So do people consider in games to use it for future products or titles?
So there's a guy on Twitter who I have a huge amount of respect for. He's a game developer called Demir, and he's made a bunch of very popular PlayCanvas games, actually. But recently he did an experiment where he went out onto the street and he did a quick scan to Splat of like a Range Rover or something. And he basically used SuperSplat to remove everything, all the background and the wheels. And he just placed that car body onto like a physics simulation of a vehicle. And he just kind of like restored the wheels, I think maybe from mesh wheels. And he just had it drive over a terrain. That video is on Twitter. Like, I thought that was hugely compelling. Because actually, as the car's kind of moving around and in relation to like the camera and also the rest of the scene, you're seeing all of the specular reflections change realistically, like the glass looking like it looks pretty good. But while that may make for a kind of an interesting technical demo, I don't think we're anywhere near a serious game developer using that in that type of game. However, I think if we maybe think of some other genres. So for example, think of like a point and click adventure game, say, where you're navigating a character around a room and you're looking for keys or clues or whatever, those kind of games. Maybe Splats would be a very good fit for that. And if you're a game developer, it would be a very, very cheap and quick way for you to digitize the assets that you need for your game. So maybe it depends on the genre. I think maybe for like, Call of Duty style game, maybe not, but maybe for, like that point and click genre, maybe. I think as time goes on and we learn more about animation, we learn more about how to integrate with physics, how to do relighting in particular, maybe this will change. But for today, I think options are limited.
Yeah, and we're actually getting a comment from Simon on YouTube who's talking about like creating a real world escape room with like different like Easter eggs and such too. And I think that's like also a really potentially compelling use case. Perhaps if I can successfully capture rooms in the Met, we can like embed some hidden things inside of it. But exactly.
No, but even let's take that one step further, right? Like, what if we built an escape room where we digitize an actual escape room, but then we turn it into like a room scale VR experience that you can run in like Apple Vision Pro or Quest or whatever. That would be super cool. So you can have these experiences at home that would feel photoreal, and it's just a really cheap way to create a game.
Right. Exactly. And, it's not as difficult as people would imagine to actually, get that up and running in terms of like capturing the imagery for that. It's something that if you were to reach out to your local escape room, for instance, I'm sure this wouldn't actually be terribly difficult to create.
Yeah, you can imagine they could do it as like a new revenue stream, right? Like they have their core business, but then they can publish digital apps where they could sell those globally.
Yeah, sure. So do you consider to support VR and SuperSplat? Is it something you want to integrate?
Well, the PlayCanvas engine and editor already support that stuff. I don't think like VR in terms of like splat editing would be super useful. I mean, maybe it might be kind of cool to be able to get in there and walk around the splat and
it's pretty fun. The Instant NGP has a way to go into VR to edit the NeRFs, and it's kind of like painting, but it's like sculpting, really. Where you're just like moving in VR. It's really it's actually very relaxing. I've actually spent a bit of time doing that.
Well, actually, maybe you're kind of talking me around, Shashi. Maybe I should go and think about that some more. But I think for now, like VR in the PlayCanvas editor, so that people can build VR and AR apps is the priority. But yeah, I mean, maybe a new way of editing that's a bit more natural using VR controllers would be fun.
Yeah, you most likely know Martin Nebelong, the Danish guy who is doing his sculpting with his VR controllers, right? He doesn't even wear a VR headset. He just uses the controllers to sculpt every scene, and then he applies diffusion on top of it. So it looks really good.
What was the name of that VR sculpting tool?
Dreams?
No, not that one. The one that was managed by Google.
Not sure.
I don't know.
I don't remember that. I'll have to Google it.
Yeah. So what are some of your favorite features of like SuperSplat right now? Like what do you find yourself most using?
Well, actually, we just mentioned one, which is just being able to share a splat on a link. Like to me, that's one of the coolest features about SuperSplat is that it's browser based, nothing to download, nothing to install, and in terms of like accessibility, that's a big deal. So that's probably my number one favorite aspects to the tool. In terms of like an actual feature built into the application, I'm really quite excited by the histogram view at the bottom. And at the moment, it's a little bit rudimentary, but I think there's a huge amount of potential there to allow you to analyze, inspect, explore, and potentially manipulate in the future splats just by visualizing the data as like a histogram. So yeah, early days with that, but pretty excited to see where it's going to go.
Do you have like a expectation or thought about like what a potential ceiling of this technology might look like? I know we talk about like it's not ready right now for maybe like AAA games, but like 10, 15 years down the road, do you see anything that would really be a hard ceiling for this technology to break through?
Oh my goodness, that is a really good question. I can't possibly think 10 to 15 years in advance. That's like, I can barely think 2 or 3 years right now based on the speed at which things are developing. But I'm pretty confident that we can solve problems around animation, convincing animation, within the next couple of years. And then we'll be able to also leverage physics. I think one area that I'm kind of wondering a little bit about the sort of like the ultimate fidelity we can achieve when it comes to like relighting Gaussian splats, because that's, I mean, especially actually. Well, I'll tell you what else actually I think I'm a little bit unsure about is how we're going to get good results from transparent surfaces, because that's one thing that, or like highly specular surfaces, because if you've seen with splats, like you basically represent that by having splats on the other side of the surface. So if you have a mirror, you have like a duplicate essentially of the room, the other side of the mirror. And for certain types of objects, that doesn't really work well if you have like small glass objects or so like solving those problems as well using this technique. I'm not entirely sure how that will be done, but we're already at the point where you can achieve very convincing photorealism, especially if you have very sort of furry, hairy, diffuse surfaces. So anything like fabrics and those sorts of things look absolutely stupendous rendered as 3D Gaussian splats. But when it comes to like let's say you had a crystal skull or something, like those things don't tend to work quite so well.
How about animations? Because you were talking about it. Do you plan to support a 4D variant of Gaussian splatting? Is that something you're considering? So that you can also clean up 4D versions?
So in SuperSplat, you have a scene manager in the top right. No, in the top left, sorry. And you can add multiple splats there. And it got me thinking that we could list frames of animation there. Maybe this is a different thing. So you've got like scenes, but also each scene can have like a number of frames. And by default today, you just have one frame. But we could have it so that you could actually list out the frames, and you could scrub through them, play them back. You could clean up individual frames, whatever. But I think the thing that I'm not entirely sure about is what the future techniques are going to be for 4D GS. Whether this is going to be like genuinely like a fourth dimension, so over time for each of the properties that you have stored in the PLY file, or whether it's going to be some kind of like interpolation between frames where you're basically like essentially morphing between frames over time. I mean, it's not an area I've even researched or looked into. I really know very little about it, but animation is clearly super important, and if SuperSplat can help support those workflows, then I'm going to be very interested to work with the people that are writing the papers to implement this stuff.
Yeah, also some kind of rigging, right? Because currently the 4D or dynamic Gaussians, they're just recorded and you can play them and replay them. But how about rigging them, right? So that you can apply custom animations.
Yeah, right. Yeah, doing either like procedural animation. I mean, one thing I started talking to Donovan about actually a few months ago was it'd be cool just to do a quick implementation of standard skinning, right? So you would have a traditional hierarchy, and you would basically skin the splats to the bones that you're animating. And I suspect that that would look pretty good. I mean, facially, it would look a bit lame because you wouldn't have like facial animation. But in terms of just like doing basic locomotion and stuff, you could probably do that now for it to look like pretty decent. You could take a motion capture sequence and just like, you could retarget hierarchy to like a splat, and
yeah, you know what? Because mostly the tools are doing this. If you see the animated heads in Gaussian splatting, it's often the flame model. They're using a model which is just a mesh, and they bind the Gaussians to the mesh just to make it look better, and then they reanimate it. I'm not sure really if this is the future or if we will have this like with pure Gaussian animation. I don't know, but currently it's like the best way to get really good results with combining meshes and splats. So yeah, I'm very curious where this will go in the future.
Yeah, I mean, it's just something I want to keep tabs on, but we haven't really reached, or at least the research community hasn't really reached a consensus around any of this stuff yet. So I think, we have to let it play out for a few months more.
And so we have another question in that. So right now, SuperSplat is purely for visualizing trained PLYs. But what someone wants to know is, in the future, would it be possible to integrate more closely to locally trained platforms like NeRF Studio to, once it's been trained, kind of have a direct, loop into the two, or is it mainly going to be export the PLY from NeRF Studio and drop into SuperSplat?
Yeah, well, I mean, it would certainly be possible, but I wouldn't want to spend too much time doing like a tight integration with like specific applications. But maybe we can come up with a way to, I don't know, create some kind of API or service to allow you to like spawn SuperSplat easily and throw some data into it and pull data back out again or whatever, so that people can write their own integrations. But for now, I definitely want to keep the platform very simple. And we could, because here's the thing, I think often it's the case that people think, well, do you know what? I could save users 30 seconds if like I built some like super complex integration or something. But is that really the top priority? Is that like the best thing that we could be spending our time on? So I'm always kind of looking at the return on investment. And we've just been talking about like 40 GS. Now, to me, that's super impactful. If we could crack that one day, wow, amazing! It's going to transform everything. But like, spending lots of time on integrations and stuff, I think has limited value. I'm not saying it's not worth doing, but I guess I've got a bit more skepticism about that.
And so along those lines as well, like what do you imagine SuperSplat might look like over the next 6 months to a year? Or are there any like things that you can talk about that you're excited about?
Well, if we rewind back to earlier in the conversation, where I was sort of saying that like we started with this ambition to create this like roadmap stretching a couple of years in front of us, but actually the way we've ended up working is just been quite reactive. But I would say that SuperSplat is, we'll continue to build out features and make it more powerful. I think areas that we'll be focusing on will be performance, compression. We've mentioned animation, visual fidelity, and I mean, for example, I mentioned copy and paste stuff. Well, that's going to take, that sounds like a small feature, right? Isn't it just like you select some splats and just duplicate them? No, we have to actually re-architect the entire backend, because the way we store splats, the splat data at the moment, needs to be completely changed. So that, like, it's just funny, whenever we develop a relatively modest new feature, it can often have like huge knock-on effects to in terms of like the architecture that we've built. And again, it's like that's something that we have to be really careful about. So just not generating too much technical debt, keeping things simple, keeping things flexible, so that we can keep developing, keep the velocity of the features and releases coming out. So hard for me to make like specific predictions, but ultimately, like I said, the goal is just to kind of empower creators, unlock people's creativity.
Mm-hmm. And let's maybe talk about the development process. If someone is motivated, want to contribute a really cool feature, what would be the best way? Just reach out first to you or create a pull request? Because you have your agenda, and I think you are following it very closely. But if someone wants to implement something very different from what deviates from your agenda, is it something which is possible?
Yeah.
You support this trend?
Yeah. So obviously developers are welcome, more than welcome. Like I'm ecstatic when we get pull requests from open source contributors. But what I would stress is that developers should first log an issue on the repo, and then we can have a community between the team and the community. We can have a conversation about whether this is a feature that we actually want, whether it's a good idea to implement in the first place, whether there might be a better approach. We can talk it over, because like the worst thing is when somebody submits a pull request and you have to say to them, sorry, you spent a week working on that, but like it's not something we can merge. Like I say, we like to have conversations with our developers and our community. So come and talk to us. Tell us what you want to do. Tell us how you want to contribute. Tell us how you want to be part of the SuperSplat family, and we'll go from there. But yeah, it all starts with a conversation.
Okay, so I see. So it would be certainly possible to say, like a student who's doing a semester project, contact you and say, I want to develop something. Do you have some support for me if I contribute some code?
Yeah, actually, I was contacted on Twitter this morning by somebody who wrote a research paper about deforming Gaussian splats, just saying like, hey, do you want to work together? And so I just said, come and join our Discord and we can talk about it. And so in the help menu of SuperSplat, there's a link to our Discord channel that's dedicated to Gaussian splatting. So if you're interested in Gaussian splatting, even if you're not really a PlayCanvas user, come and join that Discord and come and talk to us, because like we love this stuff. So.
Yeah, so where else then can like if people just want to kind of follow along the progress of SuperSplat, like where should people just be directed to of any audience?
Well, I would definitely recommend watching the SuperSplat repo. That's number one, because then you'll get all of the feature requests that come in forwarded to you, and you'll see all the conversations going on, and you'll also get an email notification every time there's a release. So it has all of the release notes, and it typically has like a little video showing the new features, which is kind of cool. And then also the other thing to do is, well, I mean, consider maybe following me on X, because I do talk about this stuff quite a lot. So just to promote my own account there. But.
Nice. Yeah, no, I love the videos that you create to illustrate all of the release updates too. So, definitely follow Will's account. It's very helpful to visualize all the new features, and a lot of times you'll post them in action. So it's good tutorials.
Yep.
Yeah, there are a lot of previews you show before they got released, so it's very exciting to follow you.
Thanks.
So yeah, I think we're pretty much at time right about now. But yeah, definitely wanted to say, thank you, Will, for joining us today on the View Dependent podcast. And we're definitely very excited to watch SuperSplat continue to grow and just continue to use it, in our everyday workflow. So yeah, thank you so much for both creating SuperSplat and then also coming on the show to talk to us about it today.
Well, thanks so much, Janusz and Michael. I've really enjoyed the conversation.
Thank you for having you here. And always when we're talking with people on this podcast who are editing splats, they're always saying, okay, I'm using SuperSplat.
Cool.
Awesome. Cool. Well, let's